Okay, for example 6 and 7, we are going to be comparing z-scores from two different events. And when we're analyzing them, you need to make sure you're understanding what you are looking for in the problems. So first, let's start by reading through this problem. Olivia ran two different races. So right away, we know we have two races. Her local 5K race. So I'm going to take some notes. So we have the local one. And it said her average time was 27.0 minutes. With a standard deviation of 3 minutes. For a regional 5K race, so that's our second one, the average time was 25.5 minutes with a standard deviation of 2.5. Olivia finished the local race in 23.5 minutes, so that's our X value. And the regional race in 22.5. Again, another X value. Compare the local averages. In which race did Olivia perform relatively better? So we are comparing average times to run a race. So you need to think when you are comparing them, is it better to be below average or above average? Because depending on the situation, sometimes it's better to be lower and sometimes it's better to be higher. For this one, because it's the amount of time that she spent running the race, it's better to be below the average times. So I'm going to make a note over here so that I don't forget what I am looking for once I get my z-scores, because it's not always going to be the largest or the smallest. It changes depending on the problem. For this one, it is better to be below average. So if we want something that's better or lower than the average, we want the lower z-score. Oops, sorry. So for these, you don't even need to find the probability of someone getting that time or less. We just need to compare the z-scores to figure out which race she did better in compared to the average. So if we look at these two, we're going to solve using our z-score equation, which again, you do need to have memorized. You're going to take the X value, the 23.5, the amount of time it took her to run, minus the average, 27.0, and divide by the standard deviation. Make sure you type it into your calculator correctly. So you should be practicing to make sure when you get to the test, you get these answers. And this one you would get, when you type it in, negative 1.16, repeating, 6666. So because our z-score table only goes to the hundredths, we're going to round to 2 decimal points. So this is going to be about negative 1.17. There's our z-score. And now we're going to compare that to the z-score of the regional. So her z-score is negative. So she did run it faster than the average. And if we look, her time of 23 minutes was less than the average. So it makes sense that it was negative. For regional, she ran it in 22.5, which is also less than the average. So we should get another negative z value. Plugging this into our equation, we would type 22.5 minus 25.5, and then we would divide that by 2.5. This z-score, when you type it in, you should get negative 1.2. So you need to make sure you answer the question. They want to know in which race did Olivia perform relatively better. So because it's relatively, we're not just looking at how much time it took her to run, we're comparing it to all of the other runners in these two races. So because we want her time to be lower than the average, we're trying to figure out in which race she did better than the average times that the runners had. So if we look, the lowest she got for her z-score was negative 1.2. So that means she did better in her regional race compared to the people she ran with than she did in the local race because she was lower than more people in the regional one than the local. So for our answer, she did relatively better in the regional race. So when you are comparing z-scores, you want to check, is it better to be lower or is it better to be higher? All right, if that makes sense, you can skip to the next video. If you want more practice, you can pause, try the next problem on your own, and then hit play and then go through that example as well. Okay, example 7. This one says Jordan took 2 final exams. So again, we are comparing 2 different situations. First one was the math final, which had an average score of 78 with a standard deviation of 6. While the science final, so that was our second one, had an average score of 82 with a standard deviation of 8. Jordan scored an 87 on the math final and a 92 on the science. Compared to the class average, which exam score was relatively better? So for the last one, it was race times, and it was better to be faster in the race or get the lower time. These are test scores, and typically with test scores, you want the highest score, or you want to be above the average. So for this one, we are looking for the ones that are the largest z-score. So it is better to be above or to be higher. So for this one, just so we remember what we're looking for, the larger z-score. Because it's better to score higher than it is to score lower on a test. So again, using our z-score formula, we're going to plug everything in. So he scored an 87 on his math, minus the average of 78, and we're going to divide that by the standard deviation. That will give us a z-score of 1.5 if you type it in correctly. Then we're going to find our science z-score. So he scored a 92 on this, minus the average of 82, divided by our standard deviation of 8. When we do that, we'll get 1.25. Okay, so both of these, he did get above average on his test scores, but we want to figure out which one he was more above average or the highest z-score. And if we look, we have 1.5 and 1.25. So that means his math test score was more above the average than he was in science. So for this one, when we compare it to the averages in the class, he scored relatively better on the math test. So Jordan scored relatively better on the math test. And when you do your work, make sure it's organized. Make sure you're not mixing up which category your average and your standard deviations go with, and then your overall scores. And then you have to make it very clear which one you are picking for your answer. And the work is there to support it. So make sure you put the work on your paper as well. All right, there's one more type of problem we're going to go over today. You can go ahead to that video next.